A disease called white nose syndrome is killing hibernating bats across North America. The fungus grows into the wing membranes of bats, causing lesions to form, and bats lose water to the environment, becoming dehydrated. As the disease progresses, bats will wake up from hibernation or arouse more frequently. As arousals are energetically expensive and bats need to use fat reserves in order to fuel them, bats infected with white nose syndrome will use up more fat reserves and will die from starvation. 13 species of bats are affected by white nose syndrome. However, one species of bat, the big brown bat, does appear resistant. While the exact resistance mechanism is unknown, this species is capable of hibernating both in a high humidity environment and uniquely a low humidity environment. Additionally, this species is also known to huddle during hibernation. Through huddling behavior, individual bats can regulate the amount of water that they lose and also the amount of energy that they use. It is the goal of my thesis to analyze the influence of huddling and humidity on the energetic costs during hibernation. For my thesis, I worked with a captive colony of 20 big brown bats housed here at the University of Winnipeg. For the first part of my experiment, as illustrated on the left, bats hibernated in 2 temperature and humidity controlled incubators. Half the group underwent the high humidity environment, and half the group underwent the low humidity or dry treatment. I found that bats in the dry treatment drank at twice the rate as bats in the high humidity environment. However, interestingly enough, they didn't change the amount of arousals that they exhibited, and thus they didn't change in the amount of energy that they used. I additionally measured the huddle size throughout hibernation period, and I found that the bats in the dry environment huddled in a denser cluster size. This indicates that the bats reduced their amount of surface area exposed to the dehydrating environment and were able to both replenish and reduce the amount of water loss. This provides evidence that big brown bats do regulate the amount of water that they lose, providing a mechanism behind the resistance. The second part of my experiment, I used a method called open flow respirometry, as illustrated on the right. In this, I measured both the oxygen consumed and the carbon dioxide produced, which are indicators of energy usage. I also measured the amount of water that they lost to the environment. In my trials, I measured bats roosting solitarily and huddling in a group of 5. While I'm still working through the results, I expect bats roosting alone will lose a greater amount of water and use more energy throughout the hibernation. Overall, my thesis will provide evidence that humidity and huddling will influence the energetic costs associated with hibernation. Thank you.